Alright, so now that you finished learning how to simplify rational expressions, we're going to take it a step further and learn how to do more algebra with them, more specifically multiplying and dividing in this case. We're eventually going to get to adding and subtracting, and that's going to come afterwards. So some things to remember. Remember that rational expressions are fractions where both the numerator and denominator are polynomials. So some things to remember, and again, some of this is going to go back to elementary school, but the same principles will apply here. When you multiply fractions, remember you multiply the numerators and multiply the denominator, so something like 2/3 times 3/4 times 1/7, let's say. We'd multiply the numerators together, so 2 times 3 times 1 to give us 6. Multiply the denominators together, 3 times 4 is 12, times 7 gives us 84. So we get 6/84, which of course would then reduce down to 1/14. Okay, so remember that's how we multiply fractions. We're dividing fractions. There was one little thing that we had to do. We had to multiply by the reciprocal. So again, just as a recap here, let's say we had 3/4 divided by, let's say, 2/5. Okay, this would be the same thing as 3/4 times 5/2. So remember, we take the reciprocal of the second fraction, take the reciprocal of what we're dividing by. So then this would become 15/8. Okay, and again, to simplify fractions, what you're looking for is to divide the numerator and denominator by the largest common factor. Okay, so here in this case, 6/84, we divided both top and bottom by 6. This one does not reduce any further, but again, if it did, we just find the greatest common factor between the numerator and denominator and factor it out, divide it out. Okay, so some general rules to follow when you're multiplying and dividing rational expressions. And if you follow this, it becomes a lot less likely you're going to make a mistake. So first thing you want to do is express everything in terms of multiplication. So that means anything that's division, change the division to multiplication, remember, by multiplying by the reciprocal instead. Okay, you want everything to be fully factored. Okay, so sometimes they'll be nice enough to give it to you in factored form, sometimes everything will have to be factored. Everything needs to be fully factored. That includes all greatest common factors taken out, including any negatives that are leading terms, because you want everything factored the same way so that it's easier to see if anything's going to simplify. Because the next thing you're going to do is do the multiplication where you multiply all your numerators together, all your denominators together, so you have one giant numerator, one giant denominator. When that's done, you can start seeing if anything's going to cancel. Okay, so if you have any common factors, both numerator and denominator, anything, basically doing exactly what we did last lesson, you're going to cancel those out. Then you can state your final answer and then look at any restrictions that might be present. So remember, going back from last lesson, the restrictions you would state would be ones that would no longer be obvious from the final answer. So look at things that were canceled along the way, and if there was a factor that canceled out in the denominator that's no longer present in the final answer, you want to make sure that you include that as a restriction. And it says be careful, the problem originally involved division, so we'll talk about that when we get there. Okay, so here's a couple things to simplify first. So again, the first thing you want to do is notice that everything's in terms of multiplication here. So let's just multiply everything together. So we have 4 times 3mn squared. So that's going to give me 12mn squared. And I have m times 6n, which is 6mn. Okay, so at this point you look for anything at all that can cancel. So for example, you have 12/6, so we know 12/6 cancels down to 2/1. Okay, you'll notice that we have an m in the numerator and m in the denominator, so those are going to cancel. And here we have n squared and n, so one of those n's are going to cancel, and be left with an n up here. So what's left? In the numerator we have 2 and n. In the denominator we just have 1, so it really just becomes 2n. Okay, so I'm going to write my final answer here of 2n. The other thing I have to ask myself now is, are there any restrictions I have to worry about? So again, there's no denominator in the final answer, so from the final answer it looks like there's no restrictions on anything. However, look at what was canceled along the way. So originally we had an m in the denominator, and it was canceled off. We can no longer see an m in the denominator of the final answer, so you have to add a restriction here that m cannot be equal to 0. Okay, and similarly you can see the same thing with n. Again, we have an n in the final answer, but it's not in the denominator, so it's no longer clear from the final answer that n was originally in the denominator, so we have to also include that n cannot be equal to 0 as well. Okay, so once we have this, we've now multiplied them together, simplified as far as we can go, and we're done. Okay, so similarly, let's take a look at B. So in B, again, everything's already in multiplication, so there's no need to change anything there. But you'll notice that nothing's factored here, so everything needs to be fully factored. What I'd like you to do first now is take a minute, factor each of these quadratics here, so x squared minus 11x plus 24, x squared minus 6x plus 9, x squared minus 9, x squared minus 8x. So start by putting the factored form for each one of these in its correct spot, then we'll take it forward from there. Okay, so hopefully you got your factored forms correct, so you can check them there. If you've made a mistake, please try them again. So now from here, again, the next step says to multiply everything together. So you're multiplying these two fractions together, which means the numerators get multiplied together, the denominators get multiplied together. Now I don't want you to expand them and simplify and put them back in a standard form. That would be counterproductive, because if it's in standard form, it's hard to see what cancels. So what I really mean is, again, just do the multiplication, put everything over one common denominator. Okay, and then once you're in this situation, it's a lot easier to see if anything's going to cancel. So now we can take a look. We got an x minus 3 here that's going to cancel off with this one. We have another x minus 3 here that cancels off with this one. We have an x minus 8 that cancels off with 1 down here. So all we're left with now is x plus 3 over x. So all we're left now is to look for the restrictions. So again, let's take a look. Anything that was originally the denominator could be a restriction. So you can see here we had x minus 3 in the denominator, and they canceled out, and there's no x minus 3 in the denominator, the final answer. So this tells us that we have a restriction that x cannot be equal to 3. Because if x was 3, this bracket would be 0, which makes the entire denominator 0, and as we know, we can't divide by 0. So the other restriction that we have to look at here is we had x minus 8 in the denominator. You can't see it in the final answer anymore, so you have to say that x cannot be equal to 8 as well. Okay, so it simplifies into x plus 3 over x, where x cannot be equal to 3 and x cannot be equal to 8. Okay, so here's one I'd like you to try on your own. Remember this one's originally division, right? So the first thing I want you to do here, if you recognize this division, is first off change it into multiplication. Okay, so in doing so, what you're doing is taking the reciprocal of the second fraction here. So you can see the reciprocal has been taken here. And then now it's become multiplication. So once you're in that position, all of a sudden it becomes a lot like some of the ones that we've already done. So what I'd like you to do now is to now factor everything. So again, everything needs to be in fully factored form. And once it's factored, see what kind of canceling you can do, and let's see what you get for a final answer. And then I want you to think about the restrictions as well. So take a couple minutes to try and finish this one up from this point on your own, and then we'll take it up together when you're ready to go through it. Okay, so you can check your factored forms here, and again, really important that you remember one of the rules of factoring just to make your life a lot easier. Make sure if the leading term is negative, that you factor out that negative. Okay, you don't want any negatives hanging around inside the brackets here. It's a little bit hard to see what factors might cancel and what ones don't. For example, you'll see here that let's say you didn't take out the negative here and you factor it anyways, you might wind up with a factor of negative 2x minus 1 x plus 2. And the problem with that is when you see you have a negative 2x minus 1 in here, it's a lot harder to see if this would actually cancel with this 2x plus 1 down here because the negative is not factored out. So you don't want this over here to be the case. You have to make sure that negative has been factored out. So once you have this, simply a matter of multiplying everything together so it's all under one denominator, and then canceling as much as you possibly can. So you have 2x plus 1's that cancel, 2x minus 5's that cancel, x plus 2's that cancel. So all you're left with in the end here is a simple x minus 3 all over 3x plus 1. And again, we just have to ask ourselves, okay, what are our restrictions going to be? So again, always start off with seeing what was canceled along the way and see if that's present in the final denominator. So 2x minus 5 was canceled out. I don't see that down here, so that means we have a restriction that x cannot be equal to 5 over 2. Okay, let's move on. 2x plus 1 was canceled. Oh, okay, it's not in the final answer anymore, so x can't be negative 1 over 2 either. Okay, x plus 2 was canceled, not in the final denominator, so x can't be negative 2. And on the surface, you might think you're done here, but one of the things that was mentioned way back when I was outlining the steps is was when you're doing your restrictions, be careful if the problem was originally division. So looking back here, in the original question, the denominator was from the negative 2x squared plus 11x minus 15. Okay, and that was moved to the numerator when we changed it to multiplication, right? So you might forget that these factors right here, which came from there, were originally in the denominator. Okay, and you don't necessarily see that anymore because, again, the first thing we do is change the problem from division to multiplication. So we also have to be careful of what was in the denominator of the original, which means we have to be careful of these factors as well. So the 2x minus 5, okay, well, that was already canceled out. We already dealt with it. But now this x minus 3, okay, there should be a restriction because of that, because it was originally the denominator up here. And if you see in the final answer, we have an x minus 3, but it's not in the denominator. So it's not obvious anymore that there was a restriction from this x minus 3. So we have to add another restriction here saying that x cannot be equal to 3 because the problem was originally division. So that has to be there. So always make sure you check, again, see what factors are canceled out along the way, and then see if the problem was originally division, any factors that were in the denominator of the original problem. Okay, so just keep that in mind as you're going through your restrictions, but just one extra little thing to watch for. Okay, with that in mind, I'd like you guys to try this one on your own now. So it's division, so again, do what we did before. Change it to multiplication, factor, multiply, see what you can get, and see what you get for restrictions. So give that a try on your own first, and push play and you're ready to go through it together. Okay, so take a look at the final answer there. If you didn't get that, then we'll go through the steps together. If you did get it, feel free to move on and try the next one. But again, just to double check the factoring here. So again, first thing, I changed this to multiplication. So I took the reciprocal of the second fraction, changed the division to multiplication. So that was a very good start. The factoring here, there's some trickier ones in here. I have to be sure we can do all the types of factoring. So 16x to the fourth, for example, minus 81. Okay, that's actually a difference of squares, right? First term's a perfect square, second term's a perfect square. So you can use an array to factor it, but hopefully you recognize that this is going to be equal to 4x squared minus 9, and then 4x squared plus 9. Now what a lot of people will do there is they'll stop, and they'll think, okay, I've factored the difference of squares, I'm done. But if you actually take a closer look, this first binomial right here, 4x squared minus 9, is another difference of squares. So that factors into 2x minus 3, 2x plus 3. And again, this 4x squared plus 9 is still hanging around. That hasn't gone anywhere. Okay, so if you're wondering where that first part of the factoring came from, that is all coming from 16x to the fourth minus 81. Okay, so 4x squared plus 12x plus 9 is a perfect square trinomial. It factors into 2x plus 3 all squared. This is a complex trinomial. It factors into this down here. And this one, the other type of factoring that, again, tends to get looked over a little bit, so just make sure you can do it, is grouping. So this one down here, the four-term polynomial 4x cubed minus 28x squared plus 9x minus 63. So remember, to group, what we do is we take each pair of terms and factor them separately. And if the grouping is going to work, what you're going to see is what's left over is going to be common factor. So common factor between 4x cubed and minus 28x squared is 4x squared. You're left with x minus 7. Between 9x and minus 63, you have a common factor of 9. And we have x minus 7 left over. So this is going to factor into, you see that x minus 7 is now a common factor from here and from here. And you have 4x squared plus 9 left over. Okay? So that's where this last part of the factoring came from as well. So now at this point, just cancel as much as you possibly can. So I'll get out my purple marker here and see that the 4x squareds plus 9 cancel. I have 2x plus 3's that cancel here, but nothing else cancels there. So I have 2x minus 3 and then 2x plus 3 all squared in the numerator, then 2x minus 7 in the denominator, so it becomes x minus 7 all squared. So at this point now, I just simply need to look for restrictions. So again, let's start with what was canceled. So I have a 2x plus 3 that was canceled here. It's not in the denominator in the final answer, so that gives me a restriction that x cannot be equal to negative 3 over 2. 4x squared plus 9 canceled, and I don't see that in the final answer, but why is there no restriction here? Well, that's because if I have 4x squared plus 9, remember, the restriction would come from the value of x that makes that factor, that bracket, equal to 0. But if you try and figure out what that x value is, I'm going to wind up with 4x squared equals negative 9. So solving for x, I'm going to get x squared equals negative 9 over 4. And you cannot, when you're solving this, trying to take the square root of x, you can't take the square root of a negative number. So this actually has no solution. So even though this was a factor that canceled from the denominator, there was no x value that could have made that factor 0, so there's no restriction that comes from it. Okay? Then last but not least, what we need to be careful of is looking at the original problem, which was division. So remember, anytime there's originally division, look at the original denominator, 4x squared plus 12x plus 9, and try to see where that went. So it became the numerator in the second line, and then that factored into 2x plus 3 all squared. So if there was no 2x plus 3 in the denominator of the final answer, because this was originally denominated in the original question, there had to be a restriction for that one. Now, there isn't a 2x plus c in the denominator,